Welcome back to Wes Explains Best. We're going to be doing a couple different sections in this unit. The first of which is 8.3, which is multiplying binomials. To understand multiplying binomials, let's first consider area. So we have a couple problems here, and it's just asking us to find the area of each. We have a rectangle, a real basic rectangle. Maybe that rectangle doesn't appreciate me calling him basic, but it kind of is. So we have this rectangle, and it's 5 by 8. And you should recall that the area of a rectangle is length times width. So what would be the area of this particular rectangle? Well, area would be equal to 5 times 8, or 40. Okay, now let's move on to another example. This time we don't know the length of one of the sides. So what would be the area? Well, it would still be the same formula, which is area equals length times width. But this time we only know that one of the sides is 10 and the other is x. So the area is just 10x. We can leave it like that. If that's what we're given, then that is what the area is. And here's our rectangle, just outlining it. Let's go even further. What if we don't know both the lengths of the sides, but we do know that they have a relationship to each other? So one is 8x and one is 2x plus 5. How do we find the area? Same exact way. Area equals length times width. So that is equal to 8x times, this time we need parentheses, 2x plus 5. Because there is addition or subtraction, we need to put that in parentheses. So now we have a little bit more work. We need to distribute. So we distribute this to both terms inside. And our final answer becomes, well, we multiply the 8 times the 2, we get 16. The x times the x, we get x squared. Plus the 8 times 5 is 40. The x doesn't get multiplied by anything, so it's just 40x. So this is our area for the third one. And that is kind of an example of just using the distributive property. Okay. Now, how can we write this? Well, in this problem, we can write the area as, we already wrote it, 5 times 8. This one was, the area was 10 times x. And if you want, you could put that in parentheses like that. And then this one, we can write it as 8x times 2x plus 5. These are all equal to the area. Now, there's another way to visualize this. So imagine you have this little grid here, and we're going to do multiplication in the grid for each one of the rectangles. So if we wanted to find the area of this little rectangle right here, we would take the dimensions which are shown. It's more of like a outline than anything. Obviously, the 4 and the 5 look like they have different dimensions, even though they're only 1 unit apart. But what we're going to do here is we're going to do 3x times x here. We're going to do 4 times x there. We're going to do 5 times 3x here. And we're going to do 5 times 4 here. So essentially what we're doing is we're doing this one times this one for this box. We're doing this one times this one for this box, and so on. Okay, I hope you guys get the point. Okay, once we do that, we're just going to simplify. So once we simplify, we get 3x squared, we get 15x, we get 4x, and we get 20. Now, which one is our answer? Well, all of them. We need to combine these all somehow. How do we write it? Well, we can say that this is equal to, the area is equal to 3x squared plus 4x plus 15x plus 20. Okay, we're going to combine like terms. You always have to be mindful of this. And once we do that, we get area equals 3x squared plus 19x plus 20. This was another way to write this problem. This was equal to 3x plus 4 in parentheses because it's being multiplied by x plus 5. Now, if you want, you can go ahead and form a grid for each one of these types of problems, but to me that takes a little bit too long, so there are a couple shortcuts that I'm going to show you just now. The first method you've probably heard before. It's called the FOIL method. This is essentially the distributive property. Now, what you're doing here is you're making sure that each term gets multiplied by all the other terms. So what we're going to do is we're going to take the 2x and we're going to multiply it. Oops, I missed it. The 2x and we'll multiply it by the 3x. And then we're going to also distribute the 2x to the 7. Okay. Now there's a special way to understand the relationship between these. So we call this the first terms. Oops, different color. Don't like that. We call this the first term because these are the first terms in both parentheses, and that's why it's called the first term. The next one we have, the next line, these are called the outside terms. The reason why they're outside is because if we're looking at this in terms of a bracket paired up, these would be on the outside, the furthest on the outside. So that's why those are called the outside. Likewise, we have to do the same thing with the 4 and the 3x. We have to multiply that, and we also have to distribute the 4 times the negative 7. Now, what we call the ones on the inside, or sorry, the ones in the middle, we call them the inside terms, and then we call these ones the last. So each one has its counter. We have first and we have last. I don't know why it's spelled last with an E. We have first, we have last, we have outside, and we have inside. And that just gives you a little bit more clarity of what we're multiplying. Okay, so for the f, what were we multiplying? We were multiplying the 2x times the 3x. For the outside, what were we multiplying? We were multiplying the 2x times the negative 7. Inside, we were multiplying the 4 times the 3x. And for the last, we were doing the 4 times the negative 7. 4 times negative 7. We need to simplify each one of these. I'm going to use a different color. Let me use blue, I suppose. We get, multiply the 2 and the 3 out front. We get 6. Multiply x times x, x squared. Multiply just the numbers out in front, minus 14x. Then we have this one, 4 times the 3, 12, and it's a positive 12x. 4 times negative 7, negative 28. Always try to combine like terms. Not try, you better. You have to. Okay, so the like terms we have here are negative 14x and 12x because they have the same power of x. So once we finally write it, 6x squared stays by itself. We do the negative 14x plus 12x, we get negative 2x, and we get minus 28. And this is our final answer. The method 2 is just to take 2x and distribute to make it like a new problem, essentially. So what we're going to do is we're going to do 2x, and we're going to multiply that by the 3x minus 7. And then we're going to take the 4, and we're going to multiply that by 3x minus 7. And then we're going to combine our answers. So what does that look like? Well, we get 6x squared minus 14x when we distribute. Then we get 12x minus 28. Now, when you see that we have like terms, we have the same combination of terms, and we arrive at the same answer. Now, I did this one a little bit more quickly just because you saw how I did it above. But essentially, you can pick whatever way you like as long as you hit each one of these combinations. The first terms, the outside, the inside, and the last terms. It doesn't even have to be in that order. You don't have to multiply the first terms first, the outside, and the inside, and the last. Foil just had a really good advertising campaign, so everyone started calling it foil. But you could call it loif if you wanted, and you could last, outside, inside first. Or you could do outside, inside, last, first. You could oilith the problem. It's up to you. But make sure you just get all the combinations. So let's do a couple examples. I'm going to use the FOIL method just because I think that's the most obvious, easiest to implement. Another way to think of it is using little rainbows to show that you're distributing it to both of the terms. So what I'm doing here is I'm just going to show you this little process distributing. So I'm going to do the 5x to the 2x and the 5x to the 1 first. So I have 5x times 2x. And then I have it's positive because the 1 is positive and the 5 is positive, plus 5x times 1, which is just 5x. Then I have, and I'm going to use a different color for this, negative 3 times 2x. That gives me negative 6x. And a negative 3 times 1, which gives me negative 3. You always have to look for combining like terms here. So we have negative 6 and 5x. And then we're going to multiply these two together. We get 10x squared minus 1x, or just x, minus 3. And there's our final answer. If I'm going too fast, make sure to pause, write down, rewind, do anything you need to in order to get this all down. But I'm trying to get everything in a short amount of time for your viewing satisfaction. Here we have x minus 7 times 2x minus 9. Again, let me stick with the color theme here. We're going to distribute the x to the 2x. We're going to distribute the x to the negative 9. So we have X times 2x gives us 2x squared. X times 9 gives me negative 9x. Then we have negative 7 times 2. We get negative 14x. And then the negative 7 times negative 9 gives us a positive 63. Again, we have like terms. They're always going to be in the middle most of the time. 99% of the time, the problems that you're given in school, they're going to be in the middle two terms. So we need to combine these. You get the idea. Okay, we use blue. 2x squared minus, because they're both minus, it's going to be more minus 23x plus 63. All right, now we're on to kind of like an advanced problem here. So what do? Well, now we have 3 terms on one and 2 on the other. What do? We can't really FOIL like we used to. FOIL is for 2 binomials. Whenever you have 2 terms like this, it's called a binomial because there's 2 terms inside, 2 terms. These are called binomials. So use the FOIL method for binomials. This is for binomials. Put a star on both sides. Star, star. Okay, so if you have this, for this problem, you need to distribute kind of the method that I showed, that I've been showing with the examples. So what we're going to do here is we're going to distribute the 3x to all 3 terms. Let's go ahead and start with that. 3x, and I'm going to write it out. The second example, I kind of did some shortcuts, but I want to make sure you guys really see this one written out. So we have negative 21. Oh, sorry, I meant to write it out. So we have 3x times negative 7. I'm going to put negative 7 in parentheses. Okay, now we need to do the same thing with the negative 1. So we're going to distribute the negative 1 3 times also. So the negative 1 times 2x squared gives me negative 2x squared. Then we have negative x, and we're essentially just changing the sign of each one of these with the negative 1. Okay. Now we need to finish writing these terms out. So this is 6x cubed plus 3x squared. This is going to be plus 21x. And then we have minus 2x squared minus x plus 7. We need to look for like terms here. We have a squared term here, and we have a squared term here. We have an x term here, and we have an x term here. So that is where we're going to combine like terms. Let's change colors and finish this problem off. So 6x cubed had no buddies. We're going to leave him alone. 3x squared minus 2x squared gives us 1x squared, or just x squared, and it's positive. 21x minus x gives us 20x, and it's positive, and then plus 7. Here's our final answer. Hope you found this section helpful. Hopefully you'll be foiling your hearts out, and good luck to you, and hope to see you next time on Wes Explains Best.